Alrighty, so today we're going to talk about acceleration. We're going to pick up the pace.
No.
No? You guys, you know what my crew know when you're all there is real funny.
Yeah, no.
I'd like you to talk about how funny I am.
Alright.
I was, I guess.
Alright, I guess.
We always made good jokes. We didn't laugh at the jokes, we just laughed at how bad.
Laughed at him.
He was a funny guy.
I'm sure my family will be thrilled to have you hear that stuff. Alright, so what does it mean to accelerate?
Go faster.
Go faster. Only go faster?
Go faster and higher.
And go slow.
Higher.
Accelerate could mean go slower, is that what you're saying, Charles?
Or decelerate.
Decelerate. Say again? Go faster at a constant rate. So speed up the same amount each time. Okay. Is it possible to be speeding up but not at a constant rate?
Yeah.
Yeah? How would you do that? How would you speed up not at a constant rate? I know a real good answer. Go for a ride with my father-in-law. You know why? Because when he puts his foot on the gas, what does he do?
Just
Hammers on it.
Hammers on the gas. Hammers on the brake. Hammers on the gas.
Oh God.
Hammers on the brake.
that sounds like my grandma.
Yeah. You know what that is? Yeah. There's actually a word for that.
Whiplash.
Jerk. It is a jerk, right? It's this nice smooth acceleration, right? That's what you want. But when you don't accelerate, that's called jerk. You'll hear about that in grade 11 physics class. The jerk factor. You'll probably hear that story about my father-in-law too. Okay, so you guys don't have this, right? But you're telling me that what does it mean to accelerate? Ruben said, speed up. You don't have it. Well, this is the preview.
Oh.
Trailers. Speed up
Or slow down. Right?
slow down, and people call that decelerate, right? Scientists would still call it acceleration. And there's a third thing that you can do to accelerate as well. Should I tell you today, or should I keep it a secret?
I don't.
Give us a hint.
Isn't it just like maintain speed?
No.
Like faster than speed limit?
What causes an acceleration?
Pressure.
You kind of know that, Jack. What causes an acceleration? What causes,
Movement.
like if I throw the tape, if the tape here is at rest, and I give it a push. Force. Force causes an acceleration, right?
Yeah.
Could a force cause something to slow down?
Yeah.
Yeah, like if I throw the tape at Ruben and he catches it, he applies a force and slows it down, right? What else can forces do?
Go through you, go around.
Turn or change direction. So could a change in direction also be an acceleration?
Yeah.
The answer is yes.
You go backwards.
All right, we'll come to that more in grade 11. So constant motion. What are the graphs like for constant motion? Constant speed. They're straight. It could be like that,
How would it be negative?
or it could be like that, right? This would just be faster, and this one would be
Slower.
slower. And both of these are moving to the.
Right.
How does it look like when it's to the left?
Downhill. So
Yeah.
you must be going backwards.
Right? This would be to the left, right? So what do you think accelerated motion graphs look like?
The top of.
It's got a sound effect. It goes, according to Brand. Are you saying,
They're not like
shoo,
straight line.
not a straight line? Do you think curved, Charles?
Not curved, but like
Like, you know.
It's like those like
it has ups and downs. It's not just
Could be both. Could be both.
Any other options?
Well, yeah, I guess you could shift gears.
Okay, so what does that mean?
Like a 5-speed.
Yeah, I know. And it makes a sound effect, yeah. Yeah, uh-huh. I knew a kid once used to do that as he walked down the hallways in school. Shifted gears. Just made the sound effect. People stayed a little wide of him.
He's too fast for them.
Yeah, that was why. Okay, so here's the part that you have. Alright, so that's a good preview there. Alright, so lesson 5, change velocity over graph. So this is what you have, right? Cars and other objects tend not to travel at the same speed all the time. Cars speed up and slow down. The changing in velocity is referred to as acceleration. Oh, what do you know? My father-in-law is online on Skype. We should Skype in and ask him about acceleration.
I'd laugh if you actually did that.
He was a teacher.
Have to teach us.
This changing in velocity is referred to as acceleration. In physics, it can mean speeding up or slowing down. So you guys got that. That's good. Speeding up or slowing down. So what would a car's... I don't have that. You have it. What would a car's motion look like when it's speeding up? I must have deleted it somehow. What would the pictures of the cars look like? Yesterday, the cars were
Evenly.
equal spacing. So what's it going to look like now, Chloe?
0 to 1, and 0 to 5, 0 to 20.
Well, there's T1. This one's at a position of 0. This one's at a position of 2. Where's T2 going to be?
The 3. Let's put it
The
3.
3?
3, yeah. Yeah, 3.
It's like a hunt.
Oh, no. Okay, hold on. Let me do math now.
That's a fast car.
Okay, so the next one's gonna be at like 20 or something.
What? Okay. So what? The pictures look like what?
It's spaced out.
Getting spaced out.
Very.
Right? Yeah. The spacing is getting what? Wider. Now you have a spot to draw a car, right? So you go ahead and draw your car and I'll laugh at your drawing. Okay, so you got your cars spaced out, right? If you were to make a table of values, what would the table of values be like? Somehow they're sort of there, but not kind of. What the heck? Can you guys see all those? You can. That's just weird. I gotta fix that. So the table of values is you got time and position. Do you guys have this? You gotta fill it in though, right?
No.
0, 1, 2, and 3. So where is it at 0? It's at 0. Where is it at 1? It's at 2. Where is it at 2 seconds? It's at 8. And then it's at 18. You'll notice that the positions are getting farther and farther and farther. How come? Because the car's speeding up.
Your left leg.
That would be a very
Yes.
fast car.
What's that?
Get it?
Okay. What's the graph going to look like? Now, can you graph those?
I'm doing another.
Should look like that, right? So you guys go ahead and graph that. Okay, notice that the graph is a curved line. This means that the velocity is always changing. This is known as accelerated motion as opposed to uniform motion. So Charles was right. Curved up and to the right. Speeding up. Would you say it's getting steeper?
Yes.
Could we put that in there somewhere? Graph is
Curved line, right?
getting steeper. Let me just see what's coming up here. Oh yeah. Getting steeper.
Here's what Jocelyn Community Cinema.
What if it was, is this speeding up to the right?
Jocelyn
How can-
Community Cinema. Okay, I'm proving him wrong. Line.
Is this speeding up to the right?
Yes.
Yeah.
Yeah. What would speeding up to the left look like?
It goes like.
A graph that has two sides, says Logan. So that it goes into the negative? So like that, you mean?
I do it like one line, then put a line in the middle.
That's what I did. So what would it look like? What would speeding up to the left look like? Okay, Charles, pay attention everybody.
I was right.
That's wonderful.
I'm on a roll today.
What would speeding up to the left look like? Let's see if you're right about this.
It goes like, it goes.
And
That just wouldn't make
Like a
sense.
roller coaster.
It goes like this, and like a.
yeah, but speeding up to I just want to start from starting from
Start
0.
From the top,
Yeah. Oh, from up here,
yeah, and then go down the opposite way.
like this.
Yeah. No?
We go down to the main room.
That's what I was thinking.
So like that.
You can't go.
So like that.
Buddy, it's out.
What do you think, Logan?
Right.
Hey? That's still. These are all still going to the right. Well, these ones are starting to the right and actually going left. These ones go below past 0. This one here just starts at 0. It goes left, but it actually is not speeding up. Speeding up, none of those are right, I'm afraid. Speeding up is actually like this. Because the graph has to get steeper. Are these getting steeper? Those are actually getting flatter, aren't they, right? You have to get steeper. This would be moving to the left. That's a little bit advanced. This time, let's look at a real example. Let's time the car is slowing down. So what are the pictures of the car going to look like if it's slowing down? Tiffany, what are the pictures of the car going to look like? Remember when it was speeding up, the spaces got bigger, so slowing down. There it is. Big space. Smaller space? That's the last one. Right? So do you see the spaces getting smaller? Go ahead and draw that.
0.
Go ahead and draw that.
What?
It's because I mess up so much, that's why. Okay, so what's the position at 0? 0. What's the position at 1? Well, the position if we're going to go by looks like the front of the car, right? Charles, get rid of that. Position at 0 is 0. The position at 1 looks like it's going to be 7. At t is equal to 2, it's 12. T is equal to 3, it looks like it's 15, right? Getting smaller and smaller. So what's the graph going to look like? 0 and 0.
1 and 7.
1 and 7.
Oh, you guys just went to 15? That's like a 15 and a half.
1 and 7. 2 and 12. 3 and 15. So what's the shape look like?
It looks like
In fact, it's,
mountain. A little bit.
what's the opposite of steep? Flat. Shallow. It's getting flatter. As the slope gets flatter, it slows down. How can you tell from a graph whether the car is speeding up or slowing down? Getting steep means, and not T, getting steep means speeding up. And getting flat means slowing down. Does that make sense?
We do it for science with this stuff. We gotta plan something like this.
Yeah,
We gotta-
I got it all ready to roll.
Yeah, so
Not today.
tomorrow.
Yeah, I got it all ready to roll.
Yeah.
Yeah,
Tomorrow.
I'm not joshing.
Josh. Good Josh.
Okay. What's going on Thursday? Oh, right.
Whose skills? Your skills? For what?
Are you? The Skills Manitoba or Skills Canada? Oh. Then what are you going for? Oh, cool. Oh yeah, I think you guys have some exercises to do now, right? Some practice ones? Okay, you guys try those, and we'll do the answers in a bit here. How about I'll just give you answers from the start. Determine whether each graph is speeding up or slowing down. So this one is,
This one's going slow, and that one's going fast.
this one's slowing down, this one is, oh, I didn't want to be here. I want to be here. Yeah, this one is
Right, our story.
slowing, this one is
Oh, why is there one going down?
speeding up, right? Draw a picture of a car, draw a picture showing a car speeding up. I just draw hats like that. So speeding up, they would be what?
I don't know how to speed up.
Getting farther and farther apart, right?
I just draw the lines. It makes it easier.
The space is getting farther apart. Explain the difference between uniform motion and accelerated motion. Uniform is
Constant speed.
constant speed.
Or I just said the levels stay the same.
Constant speed. Accelerated motion is
When they're
actually, I was going to say increasing speed, but that's not true. What would be a better word?
different.
Changing speed would be better, I think, right?
You could put velocity.
Changing speed.
That makes it more scientific, right?
Constant speed or changing speed. Okay, draw a position time graph for the following situations. A boy leaves his locker, accelerates to a constant speed. When he gets to the gym, he slows and stops. Okay, so we'll assume he's walking positively. I'm pretty sure about that. Little joke there. He's walking positively. Pretty sure about
I'm
that.
sure he's happy with it.
Boy leaves his locker, accelerates to a constant speed. So accelerate would be what? A little bit of curve, and then constant speed would be straight line. When he gets to the gym, slows down, so what's going to happen?
He's gonna go,
It's going to get flat and stop.
what? Why? He said he stops, though.
Yeah, so stops, slowing down. You can't go from going to stop without slowing down.
Yeah.
So that means that the
So now you gotta go back down until he stops.
no, but stop doesn't mean go back to where you start. This is position 0, this is position like, say, 50, right? He's not back to the same place, right? It's the slope that matters here, right? He slows and stops, so that just means that he stays flat.
But, okay.
This right here is stopped, right? Is this what you wanted me to do, Charles? You want me to go like this?
Yeah.
So then in the.
That would be going back to where he started.
In the next graph.
So then the next graph is like that then.
A girl leaves her locker, accelerates to a constant speed, runs into a group of grade 9s, decides to return to her locker.
Well, that
Speeds up, constant speed, ooh, grade 9, stop, and go back,
I knew it.
right?
I could point out Brandon after. It took me a little while. Why did you do that? Working on
Good, AJ?
oh, yeah.
Yeah? Good, Tiffany? Yeah? Did you draw it?
The lines on the paper, it's like line. That's where I messed up.
Oh, okay.
Alright.
Okay, so now I want you to write a story for this graph. How about I give you a couple minutes?
Now, can you give me an example?
Well, I've given you two. I've given you a boy leaves his locker.
But there's not one that goes underneath.
Oh, so what? Well, just go. What's the next step? If this is going to the gym and staying there, this is going
And back.
and coming back to where you start.
Yeah, okay. No, it's fine.
So what direction is this?
Go back. Oh, so that means he went from his locker, then met up with the grade 9s, then came back to his locker, and then he's going to the bathroom, and then he comes back. Oh yeah, okay, nobody steal that, it's mine.
It's pretty popular. People are going to steal it.
From locker.
Maybe you need to. Should we state where this boy's locker is?
Let's just say in the school.
How about we say it's by the guidance office?
You see,
Well.